Okay, so we're going to take a look at some kinematics problems. All right, let me see. I've got my print off here, and we're going to take a look at a multi-part problem. We're going to get things started, not take a look at the entire problem. So, we are going to solve a couple of parts of it, but then we'll let you on your own and see where you can go. So what I've got here is both car A and car B leave school at the same time, traveling in the same direction. Car A travels at a constant speed of 74 kilometers per hour. Interesting. While car B travels at a constant speed of 89 kilometers per hour. How far is car A from school 2.7 hours later? Okay, well, in this one's going to be a weird instance in which we don't actually use what I usually insist upon, which is the SI system. Now, this is metric, but it's not the SI system. Now, the reason why is we've got the following information. Let's take a look at, let's say that we've got school, and it is here, and we have car A, and car A leaves school, and car B also leaves school. I'm just going to draw some arrows here, don't read into them too much. Red arrow is going to be A, blue arrow is going to be B. Now the reason I say that is they're actually moving at different constant speeds. A is moving at 74 kilometers per hour, and B is traveling at 89 kilometers per hour. And they leave at the same time. So I haven't really drawn these to scale. Which one is bigger? Well, B would actually be bigger. But I'm mostly getting that out there that we're going to take a look at this piece by piece, and I'm setting up colors that A is going to be red. So let's take a look at car A. Because part 1 asks, how far is car A from school 2.7 hours later? So what I'm looking for is after some time, car A has gone some distance. And that's what we're looking for. So we get the following information. We're going to find, well, we're solving a kinematics problem, so let's do delta x, v final, v initial, acceleration, and time. Let's write down simply what we've got. We know for car A that it travels at a constant speed of 74 kilometers per hour. Wait, which one do I write that under? Initial or final? It says it's constant, so that means that it starts at 74 kilometers per hour, or kph if you prefer. And since it's constant, that means it stays the same. So later on, it's still going 74 kilometers per hour. Meter. All right. Now, one thing that we don't necessarily need from this, but we can actually get some additional information here. If it doesn't speed up or slow down, if our velocity, our speed, isn't changing, there are distinctions between that, but they say that it doesn't say anything that they're changing direction or anything like that. They're traveling in the same direction, they just continue going. So in this case, our velocities are going to stay the same. Since our velocity does not change, our acceleration is actually 0 meters per second squared. It doesn't tell us that directly, but if the speed is constant and we're not changing direction, then that means our velocity is constant and we have no acceleration. Now, real quick, you may be thinking, hey, we've stumbled across 3 pieces of information. We should be able to solve for a 4th. Which one do we want? Well, they're asking us how far away the car is, so we're looking for delta x. I'm not going to solve that based on these 3 pieces of information. You are welcome to do so. You will end up with the final equation, the one that doesn't have time, and you're going to find that if you try and solve for delta x, your calculator will scream at you. Main reason why is in that you're going to have 2 times acceleration times delta x. Well, if your acceleration is 0 and you multiply that by 2 and you multiply that by delta x, that means delta x could literally be anything. This is one of the few instances. It happens from time to time, and it happens when one of the values is 0, usually the acceleration. That being said, this is one of the few instances where I can have 3 pieces of information but not actually be able to solve for the other 2. I need another piece of information. Luckily for us, they do give us one more piece of information. They say, how far is car A from school 2.7 hours later? Okay, well, let's ignore the acceleration because that's something that I kind of read into. We know that we were dealing with velocity. Okay, so we have our initial and final velocities. If we're ignoring acceleration, then the kinematic equation that we would use is the second from the bottom, and it looks a little something like this. It is delta x equals 1/2 v final plus v initial times time. There we go. Great. Let's see, delta x, what we're looking for is 1/2. V final is 74 kilometers per hour, km per hour, plus 74 kilometers per hour. I'm going to leave the units off because I'm running out of space here, but this is times 2.7 hours. Now, the kinematic equations work no matter what units you put in, but if you do not put SI units in, you will not get SI units out. Or at least it's very unlikely that you will. I don't know, there might be a case where you might. But that's what the SI system is designed for. If we put SI into the equation, we'll get SI back out. So I can put in kilometers per hour, but I'm going to have to pay close attention to my units, and what I get out probably won't be in meters. So something to think about. Let's see what we've got. I've got delta x is equal to 1/2 times 74 plus 74, that's 148. So we've got 1/2 times 148 kilometers per hour. Now the 148 is from 74 plus 74, and I'm going to multiply that by 2.7 hours. Now, I would recommend that you pay extra close attention to units, because if we're not using the SI system, the units might get tricky. On the upside, I have kilometers divided by hours times hours. Our hours are going to cancel out, and the units we're left with are kilometers. When we get our answer, it's actually going to be delta x in kilometers. On the upside, they actually want us to answer in kilometers as well. They may not have that specified, but just in case. Okay, so I multiply these out, 1/2, so that'll be 74 times 2.74. Yeah, no, sorry, 74 times 2.7, or 1/2 times 148, etc., etc. And I end up with, car A has gone a whopping 199.8 kilometers. All right. Great. Let's double check. That's what it's expecting. So, looks like I'm good on that. Part 2. Car B. How far is car B from school 2.7 hours later? Well, we'll do the exact same thing, except with the other one. So I could call this delta x sub B, so I don't confuse them. In my case, since I'm working at the board, I use red for one of them, blue for the other, so you're welcome to use colors, or you can actually mark them with the individual subscripts. It's however you want to do things. V final B, V initial B, acceleration B, and then time for B, although they're still asking 2.7 hours later, at least in my numbers. All right. Well, we can fill in the stuff. In this case, we know that both of these are 89 kilometers per hour. And honestly, it's a repeat of what we just did a moment ago. Now, the acceleration, because it's a constant speed, the acceleration is pretty much 0, but actually doing the same thing that we did before, 89, we should end up with something like 240.3, which is indeed the answer. Okay. Let's get a preview of what the next couple of parts look like. I'm going to leave these to you. How long does it take car A to reach a gas station a distance 192 kilometers from the school? Well, first off, at least with my numbers, your numbers might be something else, but if the gas station is 192 kilometers, and I found out that they went pretty much 200 kilometers in 2.7 hours, we know that it's going to be less than 2.7 hours. All right, as a side note, it looks like they want the answer in hours, because that's kind of what we're working in. These equations still work even if you're not using SI units, but you have to pay extra close attention to the units. The SI system is, if you put SI in, you're going to get SI back out. All right, so in this case, you could go through and we know the initial and final velocities. In this case, we don't know the time. They give us delta x, so we would use a different equation to actually go through and solve that. Hopefully that won't be too much trouble for you. And then same thing for car B. All right, looks like those are the parts of this question.